Hello and welcome to the introduction of the remainder theorem. Now this is just a follow on from our algebraic long division work, and it's all to do with the remainder that we get at the end of that division. Now there will be times where it's handy for us to know what the remainder is, or maybe we know some information about the remainder so it helps us work something out. Now, to go through that process of long division is quite laborious. Just to get the remainder is a little bit pointless. So that's where this remainder theorem comes in handy. It basically gives us a quick way of being able to find the remainder after a division without going through the long division process. The remainder theorem is here at the top of the page. It basically says when a polynomial f of x is divided by a linear expression x minus a, then the remainder is f of a. Now we need to be careful with that linear expression x minus a. So that value a there is being subtracted from x. Now the remainder is given by f of a, just means that we can take this value a and substitute it into f of x. So we substitute our x values in the polynomial for that a value. And the output, whatever we get out, is the remainder. So let's have a look at a couple of examples. First example says, find the remainder when x squared plus 3x plus 5 is divided by x plus 2. So we know by the remainder theorem that if I'm dividing a polynomial here by a linear expression, and if that linear expression is of the form x minus a, then the remainder is given by f of a. So please note here that we have an x plus 2. In this case then we could also write that as x take away negative 2 if we wanted to. So our a in this case is negative 2. And now all I need to do to get the remainder of this division sum is substitute that negative 2 into my x squared plus 3x plus 5. So in that case I would have f of minus 2, which is given by minus 2 squared plus 3 lots minus 2 plus 5. Quick calculator job, or that's 4, take away 6, add 5, which gives us an answer of 3. So the remainder, if I was dividing that polynomial by that linear factor, would be 3. Next example. Now this is where the remainder theorem is more handy. Obviously when we are dividing, we would rather than the best types of division that we get are where there is no remainder, meaning if there is no remainder then your linear expression is a factor of that polynomial. It fits perfectly into that polynomial with no remainder. Now you can pause the video here and have a go at this if you want yourselves before I have a go now. So to show that x minus 2 is a factor, all I need to do is show that the remainder when dividing by x minus 2 is 0. This x minus 2 is already of the form x minus a. My a in this case will be positive 2. So all I need to work out is f of 2, which is 2 to the power of 4 minus 2 multiplied by 2 cubed plus 2 squared minus 7 times 2, add 10. Again, quick calculator job, 2 to the power of 4, subtract 2 to the power of 4, add 4, minus 14, add 10, there we go, f of 2 is 0, meaning there is no remainder, so therefore x minus 2 is a factor of f of x. As there is no remainder, when I divide, I haven't had to go through that long process of algebraic long division.